Alright, let's take a look at how to solve this. I'm going to give some numbers that I have created, basically as a simulation of what you may encounter. I'm not going to answer every single part, but you can feel free to ask me if you need more answered. Let's begin. So we have a file, 10 observations of x and y. I've created such a thing. We have a column for x, 10 values, a column for y, also with 10 values. We are asked first to find the sum of the 10 values for x. There are many ways we can do this. We could do it by hand. The simplest way, since we're using Excel, is simply equals sum, click and drag the numbers, and this is our answer. So this would be the same as 43 plus 65 plus 7 plus 3, and so on. So this is our x. Next, we are asked to do the same for y, the exact same process. Next, we are asked for the sum of the squared values of x There are a few ways we can do this. I will start by creating a column that squares the values for x. So I'll simply write equals. The equals lets us know we're going to do some function, some computation. A2 times A2. A2 just refers to this cell here, which has the number 43. Sure enough, I press enter, and I get that square. As you can see, they are equal. Now how about for the next one? It's going to be the same thing. Click on this, times, click on that again. Now you can certainly do this manually for each one, and we'll fill up this column with the squared values. You can also click and drag. Excel understands that for each cell, we are just squaring the value in the appropriate column. As you can see, as I scroll down in the function section, it has the correct function. Now, to have the sum of that, I can simply do exactly what I did for the previous sum. Now we want the sum of the products. So how can we do this? Well, let's see which each product is, and it's going to be the exact same idea. Equals, we're going to have some function, some operation, this cell times this cell, and simply use the fill to go down. To ensure this is correct, if we want to see for ourselves, equals 432 times 2, you can see that it is doing the correct operation because we would do 432 times 2. Now we want the sum of all of these values. So simply, same exact thing, I'll put it over here. Equals sum, all these values. So that is, and here are our answers for the first parts, all of these. So perhaps this initial notation may have been confusing. If it was not, and you were just unsure how to do it in Excel or whatever software you're using, feel free to skip this part of what I'm about to say. Otherwise, it may be useful to understand what this notation actually means. This is a summation symbol. It means we're going to sum the values of x indexed by I from 1 to 10. For example, this is the first value, this is the second value, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th value of x. So in the case of the sum, and this notation, x1, this should be subscript, is 43. x2 is 65, and so on. So simply this means adding these values up, 43 plus 65 plus 7 plus 3, and so on. And that's exactly what we've done up here. In Excel, this notation just means from A2 to A11, all the cells from 43 to this 432 will be summed. It's the same exact idea for Y. And now for this, very similar. x1, again, is 43. What we do first is we square it. 43 squared is this. Then we take the next, x2, which is 65. We square it. And we just add all of these up, just like we've done right here. Same exact idea for this number. Let's move on to phase 2. So phase 2 wants us to construct an OLS, an ordinary least squares estimate, following this equation. This won't be hard. Let us first examine what this equation means. So yi, that is y indexed by the values for I, 1 to 10, what you've seen here, what exactly that means. B0, also called B0, often we use beta for this, but this is fine. So B0, this is just a constant. If you've seen equating for a line before, you're probably used to y equals mx plus b. B is the constant. It essentially has the same value as this, same purpose. X is the variable of interest, just like this xi. M is the slope, just like this. We typically, when talking about an ordinary least squares, call this a coefficient and this a coefficient. This ui is an error term. By looking through this packet, it does not seem like this ui is something you need to really understand. Just know it exists. Essentially what it means is when we perform this ordinary least squares, it is an estimate and there is some error involved based on the estimation, based on the variables we're using, confounding variables, things of that nature. So we include this to establish that there is error present. This doesn't mean what we're doing is wrong. This is how an ordinary least squares is performed. So let's see how we can actually do this. So there's many different formulas. Well, there's not many different formulas. There's many different ways to use it, many different software where you can utilize it. In Excel, we're going to do it pretty much straightforward. We'll go to Insert. We're going to have a scatter plot. I'll select the data. I'm just going to put in the data that we have here. The series name, this doesn't matter. Our x values will be our x values, and our y values will be our y values. Press OK, this is fine. So now it is matched up on the x-axis, we have our x values, and on our y-axis, we have our y values. And then what we simply do is 43 and 7 have matched up. So this looks like it might be it. This is 43 and 7, or maybe this is 43 and 7, something around that. And this looks like this is 3 and 200. In fact, yeah, so we can say this is 3 and 200, 23 and 12. Okay, so I was off on that. I think you get the idea. So these are just all the points plotted. Now we want to get an equation for them, our least squares equation. This is very simple to do. There's a formula. We can see how it's not actually laid out here. The formula is, it's fine to do it by hand with a formula by calculation, but it seems like you were just expected to do it from Excel. So I've just right-clicked on any of these data points. I click Add Trend Line. You'll notice that I have many options for the trend line: exponential, linear, logarithmic. We're going to choose linear based on the equation given to us. This is linear. It's possible, we should actually be looking down here, but it's not that big of a deal. For this, it's possible that we could have been given a log like this, where this log stands for logarithm. If this was the case, we may be more inclined to use a logarithmic regression. However, it's not, so we'll use linear. Now we are given the equation. All we want to do is display it, and we can also display the r² value. This is simply using the functions in Excel to give us the value that we want. So this lines up exactly to this. This y naught, y hat, is this y here. This b naught is this 119.38 here. This b1 is this negative 0.2574. This xi is this x here. They're basically meaning the same thing. So, what does this mean? The predicted value? Well, we're now, with this line, are going to use it to predict values of y. So, I can put in some x value to predict a y value. For example, if I said x was 100, it would look like y is maybe 98, something around that. See how this would correspond to close to 100 here? So if I plug in x at 100, y is maybe 98. In fact, let's see what it is exactly. So I'm simply going to plug in my linear equation that I was given. Instead of x, I will substitute 100. And I get 93.64. So if I were to examine this closely, I would see that where this line intersects, it's at 100, 93.64. So you are asked to evaluate when x is equal to 0. So this is what we would put in, where we have substituted 0 for x. And we get that. You'll notice that this is the intercept here. It will always just be this value. Next, you are asked when x is equal to 20. Similar approach. And we have a value. So, when x is 20, it would be right here. This is where it corresponds to about 114. Now, for phase 3, this is pretty straightforward. yi is the actual value. So, this is a yi. This is a yi. This is a yi. This is a yi. Just here. Y hat I is our computed value, as you'll see from up here. What we want to do is for the same values. What is this EI? What exactly does this mean? Well, let's compute one. What would happen if in this estimated equation I plugged in 43, a value we already have a point for? This one, in fact. Let's see what our equation gives us. Wow, we get something very different than what our data was. Notice this is 43.7. This is where the line is. You can see the difference. Now to compute this EI term, what we would do is, as you can see, subtract these. So yi is 7 compared to this value. So we'll simply do 7 minus, and this would be an EI. In fact, this would be E1. What I just computed would be E1, because I did it from the first value and plugged that into the equation. If I did it for 445 and plugged it in, this would have been E5, because this is the fifth value. 1, 2, 3, 4, 5. Let's see how much of the rest of this you can now do on your own.